All right, we have this lit code question, middle of the linked list. So the question says, give the head of a singly given the head of a singly linked list, return the middle of the linked list. If there are two middle nodes, return the second middle node. With this, all right. So what I understand from this is that they are going to give me the first node, which is the head, and then I must return the second middle node. So I must return I must return the middle node. So if it is like this, so the middle, how many nodes are here? 1, 2, 3, 4, 5. So the middle one is 3. So it means I would return this 3, which basically, if I return this node, it will return this whole, you know, uh, from here to the end. So if it is, this is 1, 2, 3, 4, 5, 6. So 6 by 2, the middle will be 3. But they are saying, basically, if I consider 3, here there are 2 left, here there are 3. So the, the middle ones here are 2 of these, 3 and 4. So in that case, they are saying we must return the second one. So perfect. So my thinking, okay. So so um so let's go through it. Given the head, return the middle node. We will return the second node if the middle ones are 2. All right. So let's see what let's first see the approach that I would take. Approach. Okay, so number one, I think uh, I need to know the size of the linked list. I need to know the size of the linked list. So know the size of the linked list. Perfect. Now, after knowing the size of the linked list, I want to use that to calculate the middle so that I'm able to know the middle, what the middle is. So number 2 is from the size, compute the middle. So so in this case, for us to know the middle, we'll use size divided by 2. Okay, but now under this we have 2 scenarios. So if we look at this, sorry, if we look at this, uh, the size of this 1, 2, 3, 4, 5 is odd, whereas the size of this is even. Okay, so if the size is odd, uh, if the size is odd in this first case, um, our thing would be let's say example, let's say e.g. 5 divided by 2. So 5 divided by 2 is equal to 2.5. So 2.5 if we return the seal of this, the floor of this would be 2, which becomes this, which is not the middle. So the seal will be 3. So it means would be at position 3. So 1, 2, 3. So that would be the correct one. The 2.5 would be at position 3 here. So so if the size of the linked list is odd, then we return um, so the middle is the seal of size over 2. So e.g. That. Now, if the size um, is even, um, what do we do? So in this case, if the size is even, let's say 6 over 2 would give us 3. So in this case, it would be 1, 2, 3. So, but now we don't want 3. We want the next one since there will be 2. So in our case, if the size is even, we have to we would have 3 plus 1. So 3 plus 1 will give us 1, 2, 3, 4. It would be the fourth position. So it would be 3 plus 1. So the middle uh, is size over 2, okay, uh, uh, plus 1, okay. So 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 uh, so this would be something like this. So middle is 4. 3 plus 1, which is equal to 4. And here we would return, so here middle is seal of 2.5. All right, perfect. So once we have the middle, then we know that we can now remember the way to go through a linked list is by just iterating. So we want that once we are iterating, once we reach the middle, we want to be able to return. So at this point, we'll have, once we know the middle, then it means that we can have a condition while iterating. When we reach the middle, we just return. So iterate until we are on iteration count same as middle. Perfect. So let's try to put this in write code for this. So we have a function that takes the head and returns the linked list, the head, returns a linked list. All right. So for starters, we want to find the size of the size of linked list. So this will take the head, and we also want to we will use the count to know the size, because as we iterate through, we want to know we want to keep incrementing a certain value. So if we go from 1 to 2, 3, we want to keep incrementing a certain variable until we reach the end. Then we'll know that we have completed uh, the iteration, and then we return. So we will pass the count. So now what we want to do is that if head equals none, now this means that as we are iterating, once we reach a point where node is none, like it means that we are at the end. So how do we know the end? Knowing the end is two ways. Either we can use head.next equals none, because the last node in a linked list, the last node points to nothing, points to its next is none. Or we can use head equals none, which means that we will have reached the end and we are trying to go to then another node that does not exist. So if in the event that we are trying to go to another node that does not exist, then head equals none. So at that point, we want to return the count. So this will stop our iteration. Uh, um, but how do we want to do this recursively? Because either we can do it iteratively or recursively, but I want to do it recursively. And if we are doing it recursively, we need to know when to stop. So we will stop once head equals none, meaning we have gone through our entire linked list. So at that point, I will call, I will just call this recursively. So once we call this one will be called, but the recursiveness of this will take the recursive function will take head.next. So it means as we keep going to whatever head we pass, we go to the next of it. This will also have its next, like that, like that. So pass head.next, and then on each at every point we call this, every time we call this function, we want to be incrementing count by one. So once we call this, so initially we will initially when we call this function, we will pass the head, which is this, and then the count will be 0. So for the first round, it will have the initial head, so this will be jumped, and then 0. So it will come here. So it will pass head.next, but also increment count by 1. Then it will go back. At that point, we'll have 1. Then the next one, this one will become 2, and now will be on the head.next.next, like that, like that. So this should return the size. So let's first print the size to make sure that it's correct. Uh, okay. Oh, so we need to make sure this is returning, because if we don't return here, then this count won't be returned. Yeah. So perfect. So we have the size. So looks good. So now that we have the size, we want to, so this calculating know the size, this is done. Sorry, this is done. So once we have the size, we are now on point number 2, computing the middle. So so uh, so going with scenario number 1, if size is odd, how do we know that it is odd? So if we have the modulus of size, if it's not equal to 0, for an odd number, the modulus the modulus will be the remainder. So if 5 divided by 2, the remainder is 1, but 6 divided by 2, the remainder is 0. So this 5 by 2 will return 1, so that won't be equal to 0. So that will tell us that this is an odd number. So middle equals to the seal of whatever we are dividing. So seal of size by 2, but we will import math. Initially this is not given, so we'll import it. So math.seal, perfect. All right, so that will give us that. So we need to note that this is for odd size. All right, so the else part will be the even size. So middle will be equals to int Um, so okay, so the middle will be uh, the size by 2 plus 1. Yeah, so to be size by 2 uh, plus 1. But this, when we divide, this will return a float. It will be like maybe 3.0, then plus 1 will give 4.0, but we just want this to be an integer. So we'll just return an integer. So this will give us the middle. So if I print middle, middle, so this should give us the middle. Perfect. So the middle is 3. So we have it right. So let's change the test case and we make this even. At this point, we will want it to be 4. Yeah, perfect. So let's run and see. Perfect. So our middle is correct. So I return this. Perfect. So we have middle. Perfect. So once we have that, so it means we have this is done. This is done. And now we want to go to number 3. So number 3 is iterate until we are on iteration count, same as the middle. So we are now on this. So we want to, at this point, that's the point when we are finding the middle node. Yeah. So we definitely want to have another function that finds the middle node. So, and in this, we are passing the initial head, of course, but as we go along, we also want to maintain the count such that we will be able to know once we have reached the middle. So we will have the count. Perfect. So in this, what we are most interested in is this statement until we iterate until the count is the same as the middle. So we want to say that if count equals middle, okay, then we return head. Yeah. So once we reach the middle, then we want to return the middle. Yeah. So that will be it. So we want to do this recursively because we are going to go through each node until we reach the middle. So middle node. So uh, so once we call this for the first time, it will pass. But as we go recursively, we want to keep returning passing the next node. Yeah. Um, all right. So and every time we want to increment the count such that we can compare where we are at in the iteration with the middle to see whether we reach the middle. So so at this point, so middle head will now be, so we want to now call this function. So this head we are passing is what is passed initially in this other main function, the parent function. So, but we want to start with a count of 0 such that once we do on the first node, we increment, like then we go like that. So let's print our middle head and then see what we have. So we submit that. Perfect. Okay. So, oh, sorry. Supposed print that. All right, looks like it's okay. Oh, but wait, we are returning from 4. So we are passing this. We want to be able to return from 3 because our middle is 3. So I want to be able to return from 3 upwards. But this returns node from 4 to 5. Oh, so the reason why this is being the case is that by the time we are on the middle, when we return the head, uh, we have already passed, uh, we are now on the next, because the moment we are in the middle, we we are now returning the next of the middle. So once we are at 3, this is returning the next. Yeah, so what we want to do is uh, we want to check, we want to return, we want to, if the count is equal to middle minus 1, so which means uh, we subtract 1, yeah? Let me just subtract 1 to return the current node. Yeah, the current also, oh, this is supposed to return the current middle node, which is the next of the previous node. So by subtracting 1, it means that we are trying to, uh, instead of equating count to middle, we are trying to consider the previous node because we know then that the next of the previous node will give us the middle. So that's if we return that. So now this returns, this prints 3 from 3. So instead now of printing, we can just return it. Yeah, return middle head. So perfect. So let's submit that. All right. So looks good. All right. So that's it. Thank you.